This is kind of a noisy attack, but I think it can be pretty much improved, but by someone more skilled and with more time than me, he has actually to restart the system. Okay, so he can just put a background show to reset the system at some time. There are also some procedures in the system administrator tasks that reset the system for time to time. So he'll need to reset the server. So to do this, he will execute a special program that's called RSBD COS 0. That is actually here. Okay, RSBD COS 0. Actually, well, he can do pretty much what he wants here because this is like a command shell through the SAP system. Oh, this is not the DIR, sorry. I'm in a Linux system. So he can execute operating system commands. And what he'll do is to run this command, stop SAP R3 and start SAP R3. Let me check. Okay. So he will run this command to stop the SAP system and restart it again. So this will take a little bit, but at some point the attacker will lose connection because the system is going down. So while this is going on, I'm going to show you what this is backdoor installer script. Backdoor installer. So this is basically a proof of concept that I developed. It's actually connecting to the database with credentials. Okay, but remember, this is not only the attack vector. The attack can come from any of the other components. And let's show this payload, the one that we are executing right now. This will be like the ABAP payload that we are injecting into the database, overwriting the original ABAP payload. So this will be like compressed ABAP source code. And it's just simple SQL queries. Okay, so we are updating the value of program SAP MSysT to this data, to this payload. So we just change the code of the program in the database. We change some more dimpros, we delete the ABAP loads, and we just commit. Okay, so that's only what the attack does. Okay, this is still not resetting. Let's see. Okay, this may take a while. I can take the chance to ask. Okay, let me see. Maybe not. Okay. I can take the chance to ask, try to answer one question if you have one. No question. Okay. Yeah, the question was if the first payload, the bank account payload, changed it every vendor's bank account or just the first one. It actually changes every vendor bank account. And it's a good question because it pointed me out something that I just showed you that the backdoor was modifying the vendor bank account, and it was actually showing you the new bank account. But the backdoor could still show you the legitimate bank account and still internally use the attacker's bank account. So it's really difficult to detect. Okay, that's a good question. Let me check if I have it running. Okay, no, I can get, yeah, well, anyway. Yeah, the question was if in the first example that I changed the old hash value, it was possible to detect that in the system log. What you would be able to detect that in the system log, if you're doing it through the SAP system, as I did, like entering the SE16 transaction, accessing the database table, entering to debug mode, you may get some information in the system log. If you do that directly through the database, you get no information at all. Okay, so the system was rebooted, and it is supposed that this logon screen is now backdoor. So what we're going to try to do now is to, let me see, log, Apache, access. Okay, so this window here will be the attacker's system in China or in Argentina, not to have no hard feelings with China. Or, so now the legitimate users will try to log into the system using his password. And it's there. Okay, so here the attacker system got a special HTTP request, and here is the client. Well, the client is in a bad format, but it's a minor bug. You have the username and the password that the user used to log in. Okay, so if anyone logs in again, I'm making a mess here. Anyone, John, with the wrong password or whatever, just to show you, you'll get John passwords. Okay, so this basically means that an attacker could be receiving any SAP user's credentials from the time he wants to. Okay. That's 3 demos running without problems. Something is going to happen today. Probably the ceiling is going to fall. So, which is the protection against this? It's actually not possible to protect against this from the SAP layer. We're going to get into that in, I think, next slide. Yes, so in order to protect against this and to help customers try to detect this kind of threat, we developed the On-Apsys Integrity Analyzer for SAP. So basically, what we're trying to do with this tool is to try to help to detect and prevent fraud, okay, like this one. So this could happen in Vegas, so watch out with what you're doing tonight. This tool will try to detect modifications in ABAP codes. You can download it, well, not yet, it's upcoming. I hope to have it running for next week as well. And it's only working, so far it's a proof of concept, it's only working for SAP with Oracle 10G implementations. It was developed by one of our guys, Jordan Santarcieri, and I kind of gave him some guidance on the tool, but the actual code was pretty much developed by him, so he gets the kudos for that. Why do you need this kind of tool? I mean, this or any kind of this approach? Because you cannot detect the backdoor from inside the SAP system itself. This is just a basic concept. If your Windows system is backdoor, you cannot use that system to check if it's backdoor. So you cannot use the SAP system. What not very security-aware auditor will try to do is to check programs' last modified date. I've seen this in auditing reports, a big 4 auditing reports. The backdoor can leave, why? Because when you modify a program from the SAP system itself, it updates the last modified dates. Of course, if you're just accessing through a database, you can leave that field untouched, as we just did. And also, the ABAP program that you're running to check if this system is backdoor can also have been backdoor to hide the backdoor. Okay, so it's like recursive. So you cannot rely into that. You may try to do this manually, but you should know that there are hundreds of thousands SAP programs in a regular SAP installation, so this may get a bit difficult. And what the program does is really not technical, it's not rocket science at all. It connects to the database and performs a snapshot of sensitive, or actually of all ABAP programs. So it's getting a hash of each ABAP program code and downloaded it to a local database. So then you can periodically make new snapshots and compare them if there is any kind of unauthorized modification. This is far from being perfect because it has some weaknesses or drawbacks, like you have to do this, for example, the first day you install the SAP system because if you do it now, you don't know if it had been backdoor before. But what you are planning to do is to release some signatures for baseline installation so you can compare against that, but it's going to take a while. And it's also important to track SAP nodes installation because they can modify ABAP programs and they are not backdoor. So it's difficult to manage. The idea is that it will help you to detect some suspicious modifications and you should do further investigation into that. So I'm going to show you how the tool looks like. No, this one. Okay. So just to make it faster, I have already taken a snapshot of one of the systems before we backdoored the business module. And now I'm going to take a new snapshot. So I had to connect to the database. You specify the Oracle instance ID, the user you want to use to connect. You can, if you don't use custom scan, it will make a signature of all the existing ABAP programs in the database. Okay, so it's going to take too long. What you're going to do is use a custom scan to scan only for and to snapshot only some small subsets. So I load this file, and you have to specify where do you want to put the output. So this will be the snapshot post backdoor demo db. So you save it. You can check connection to see if everything's working. Everything seems fine. You can proceed with your snapshots. So you run this, and it will connect to the database, get a SHA-1, I think was, hash, and save it to your local machine. So what you should do from time to time is to compare snapshots. So you go here, and you load the snapshot that you did before. So I have the one before the backdoor somewhere pre-backdoor. And now I'm going to load the post-backdoor demo file. So I hit compare, and we'll see that the business module that we modify on the database was detected to have different signatures. Okay, so then you have to make your investigations around what happened with that program. Okay, so it can tell you if there are difference in compiled programs, there are missing programs, there is any subnode related to this program, so you can try to think that maybe it was a subnode. But the idea is that you can do this with the tool. Like that. Okay. So, summing up. Also, when I did this presentation, there was like some kind of concern that, or misconsiderations that this was an SAP vulnerability. This is actually not an SAP vulnerability. I mean, the backdoor threat affects every information system, so it's not SAP related specifically. What we have just shown is that it also affects SAP systems. And also it's important to realize that once an attacker has full control of a system, it's really, really difficult to restrict his activities. Okay? So SAP is not the exception in this sense. It will be the same as saying that Microsoft, because is flown, Windows is flown because